A lot of you I know. For those that don't, I'm Mike Coelho with Coelho & Associates. I'm a third generation foundation guy. My grandfather started in the 30s doing fieldstone foundations up in Upper Peninsula, Michigan and northern Wisconsin. Then he came down into Milwaukee. In the 50s and 60s, he was one of the largest mason contractors. He had a flatwork crew, foundation crew, and also a veneer crew. My dad started when he was 8 or 9 years old with him. Worked on the job, cleaning stuff up, breaking things. Best story is at 10 years old, my grandfather had bought a brand new dump truck, and he said, hey, put this block in the back of the truck. There's a little bit of a slope there. Take the dump truck, dump it over the slope, come back and keep doing that and clean it up all day. And my dad's like, I don't know how to drive. He says, don't worry about it. It's real easy. You've seen how it's done. Well, at that time, the dump trucks were all stick, right? So he gets in and goes, dumps. Well, the problem is he forgot that the tailgate needed to go down. So he crumpled the tailgate right around the back of the truck. And that was the longest day of his life. And he remembers and tells me that all the time when things go bad at work. So I started when I was 12 years old with my dad in 1982. He did not have anybody else working for him. And so that summer, I was his laborer. And we did garage slabs for J.D. Griffith Garages and Lifetime Garages. And that's how I got my start as a concrete finisher. I worked every summer since then, put myself through college, got my degree, decided I wanted to be in concrete work, and then we started doing poured foundations in 1993. So I have a background both in masonry and in concrete. So I've learned both ways, good, bad, or indifferent. Just recently, I got my ACI certification. I am on the single family and two family code council. So that's at the state level. I was a member of the Uniform Dwelling Code Council as a co-chair for a very long period of time, and also and still am a member of the Construction Arbitration Board. For those of you that are not involved in associations with the MBA, I highly suggest it. The most I've ever learned, and the main reason that I'm a member of the MBA, is because of what I've learned with the Construction Arbitration Board. That's where I learned the better techniques of dealing with contracts and specifications and so on and so forth. So for those of you that aren't involved, highly recommend it. Today we're going to go over code compliance for foundations, which is basically the minimum. Now, the code also, the code for the Wisconsin Uniform Dwelling Code is 21.18. If you're going to refer to foundations, that's the code part that you're going to look up. It is on the Wisconsin website. You can look it up. It's about 3 pages long. I suggest going through the commentary also. All of the code requirements for any part of the code book has a commentary section. That's the section where you're going to find out kind of the background for what the codes are, why we went a certain way, or why the code went a certain way, and then what the code official's interpretation should be. Okay, because a lot of code, there's a lot of reading between the lines. That's where you're going to find the interpretation. So 21.18. Now, also part of the code, and you'll find that through any of the sections, whether it's plumbing, carpentry, so on and so forth, is also they adopt certain standards. So for foundations, they adopted ACI, or the American Concrete Institute Standard 318, and that's going to deal with concrete. And for block, ACI Standard 530. Now, individually, each of those are probably close to 100 pages long, and they also have commentary. Now, on the concrete side, the 318 really deals with the crux of the engineering behind the foundations for concrete. On 530, they'll not only deal with the engineering side, but also the specifications and what the quality control should be for putting up any masonry. So 530 will also deal with veneers and those types of things. Then we'll also be dealing with the primary functions of full depth foundations, soils, and marrying concrete with steel. Like I said, ACI is basically an international standard. So they have engineers from Dubai, China, Germany. This is an international code. And they've tested concrete for well over 120 years. And they set up what the parameters are for when you're mixing concrete, mixing masonry, putting it up, and that sets the standards. So 318 is going to give you the engineering guidelines for concrete, 530 for masonry. Now 332 I have listed here. That probably will be adopted at some point. That actually should be the code requirement for residential. That specifically deals with single and two-family homes. The code committee has not dealt with that yet, but will. But a lot of charts that you may need, and we'll talk about that, for designing foundations, you're going to find in ACI 332, which is also a different segment. There's 3 jobs for the foundation. One is to support the live and dead loads from above, pass those loads down to the soils below. That's pretty simple to understand. The hard one for a lot of people to understand is the backfill soil pressures. What is the soil putting on the foundation, and where is it putting its pressure on, and where is it going to fail if it does? The last one is not only do you got to do the top 2, but you're also going to have to keep the water out. So we're going to go through. The live and dead loads would be the picture to your left. Most foundations, that's a pretty simple thing, comes through the foundation. It also will deal with the steel. The steel's going to pass through to the columns. The columns are going to pass that down to the footing pad. Those pad sizes will be calculated usually by either the steel supplier or by the lumber supplier. Now also, which we tend to see on a remodeling side, is when you cut in an opening. So let's say you're going to put an egress window in a foundation. Keep in mind that if the floor joists are setting on that area, what are you going to do with the lintel above to carry the load down along the sides? So this is an area that we see a lot of people forget about. Also, when openings are cut in, for instance, we see a lot with spancrete. When you put an opening under spancrete, there's additional steel reinforcing that needs to go and carry that lintel. And what a lot of people won't do is figure in what that concrete lintel should carry for steel, or if it's a masonry lintel, what that lintel size should be. There are charts and diagrams, and we'll get to that. But those are areas that we see failures and that you need to keep in mind when you're adding or changing the foundation design. A little bit about the soil loads. Easiest way to think about it is that the soil weighs a certain amount. And that weight also has to include if it's saturated. So if you're talking about a clay soil, that's going to be heavier when it's saturated than a granular soil that's going to drain well. As that height builds, so we've gone from what used to be on a 10-course or 11-course basement, which was 6'8", 7'4", to now 9 foot is pretty standard. You've added additional weight to what the foundation has to account for. And the different soil types. Now, PCF is pounds per cubic foot, so 45 would be a granular soil. So 45 pounds, and then it stacks on top of itself, and that's per foot. 60 would be more like a little bit of clay mixed in, so you're getting more towards Waukesha, Muskego, outlying areas of Muskego, up north. Once you get outlying areas of Grafton, you're going to see probably a 60 PCF. As you get down to Oak Creek, Mequon, Caledonia, Racine, you're going to see the heavier soils are the 80. You can see the dramatic increase in weight. So a foundation that's built in the 45 PCF soil pressure area is not going to be the same foundation that you want to build in the 80. People don't realize that, and they build one size fits all. There are charts. The code doesn't really account for it other than the charts that they have. And that's where, when they refer back to that ACI 318, and that's why I started with that, you need to go back to the charts that they have there and go through and determine what your soil pressure should be. So if you're building in Franklin, you're going to go to that 80 PCF. If you're going to build a 9-foot basement, you're going to have to figure per cubic foot at the base is going to be over 10,000 pounds. And then determine how much steel, the width of the wall, so on and so forth, and design for that. Right now with the code, the minimum, that'll probably be fine for somewhere in that 45 to 60 range, but you get a wall that's longer than 30 feet, it's going to fail. It won't fail in the first year. It'll probably fail 5 to 10 years down the road, and that's whether it's block or poured. So you need to adjust for that, and the code really doesn't account for it, and that's why you see some municipalities now changing what they're calling out for. Menominee Falls would be one. Menominee Falls, when you pick up your permit, they tell you right off the bat, you better figure out what you need for soil to backfill up against the wall and adjust the foundation. So that's one. Muskego's another one, which is adopting similar standards. And you're going to be seeing this, I guess, become more prevalent until the uniform code is changed. Yep.
I understand Menominee Falls may be looking at all stone backfill.
Well, they are all stone if you don't have any engineering. So what they're saying is, yes, we understand that the charts in the Uniform Dwelling Code basically are good for that 45 to 60. They're saying, look, you prove to me that it's under 60 or under 45, and then you can use the on-site material. And we've worked with our builders on that, and you design accordingly. Granular soils, and they got here through the glaciers. Those are in the outlying Kettle Moraine areas. When you get out towards Madison, it's all sand. Okay? Sand easily drains. It's going to be lighter. So when you design for those areas, you need to take that into account. The Great Lakes Watershed Basin, which has been coming up if you're in Waukesha County, we're trying to get water from outside or within the watershed. That's mainly where you're going to find the clay soils. Okay, so Milwaukee, Menominee Falls, Grafton, all along Lake Michigan, you can find soils up to 120 PCF. So that chart I had to 80, I figure you could extrapolate from there. Very seldom do you find 120, but that's a really heavy clay. You're going to get into a very engineered foundation. The last one is, we're running into a lot of them where they're at the end of the subdivision. They brought in fill or moved fill, cut and filled the subdivision. What's left are non-compacted fill or organic soils. It's been there for a while. That's, the base may be compacted, but what gets backfilled up against the foundation is uncompacted, okay? They have a building pad. It's set for 8 or 9 feet. They bring in the fill. That fill does not drain well, has organic material, and puts additional pressure on the foundation walls. That has to be accounted for. We've seen that a lot, and we've seen that foundations failing over the last couple of years because that's kind of what's left as far as the subdivisions are concerned that were probably done 10 years ago. So be aware of that. This is that chart. This will kind of lay out. You can find this chart in the Uniform Dwelling Code in the commentary part, or you can find it in some other areas. Sewer Pack also has a chart similar to this. They actually, Sewer Pack, Wisconsin has a Sewer Pack website, has engineering data for wherever they put a road in, or wherever they put a sewer in. So you can find out exactly what type of soils were there and then design accordingly. So this is one of those that you can use to kind of set yourself up without having to get borings done. Difference between, you can see the cohesive soils, they're compactable. So even though you may get it within 96%, those soils will still compress and change. They also will change for density of water. I think it was probably about 7 years ago when we saw this being prevalent in Elm Grove, where it had gotten so dry around here, water hadn't gotten down to where the footings were, that the clay actually was decreasing in density and the foundations would actually drop a little because it didn't keep a certain amount of moisture to keep those soils expanded, okay? They run into this, actually Texas. They have to design their foundations for that instance where the soil changes in density due to moisture. So that's something, it isn't as prevalent, but it has occurred here. Nice granular soil. This is probably sand mixed with clay. This is what you're going to find in Muskego or a little bit outlying Franklin, New Berlin. That's going to be that type of soil.
My daughter lives in Texas, and she has relatives there, and they have houses built on slab. And when they have a long dry period, they actually have to go out and water around the foundation.
Yep, they have to keep the and you'll see that exactly. That they'll expand during wet periods, and then it shrinks actually during dry periods, and the foundations will actually change and move. So it is, when you find that type of situation, you need to adjust for it, especially if you're going to use that as your backfill material, because it will sink and settle along there, crack, and that's going to allow more water, even if you have the correct pitch, more water intrusion, which we haven't gotten to. But it becomes an issue. It's hard to tell on this picture, but the soils at the deeper section, this was just kind of as it exits the building pad. For those that don't understand where or have seen that, building pad will be laid out by the engineers that developed the subdivision. Those soils were compacted properly, have an engineer's report. If you get outside the building pad, you may run into an area that may not have that compacted or may not have suitable soils. This area that's darker, that is in the shadow. Okay, that is black kind of mixed in with the clay. And so you probably will see a difference as far as the types of soil when it's an engineered fill type situation. This one was in New Berlin. The foundation actually, that was the front stoop that caved in. So that was the fill that they used inside the front stoop. Notice it's clay. We had a wet period, wasn't decked, and the saturated clay soils overwhelmed the foundation and it just came in. There's also no steel. So you have to design, if that's what you're going to do, you got to design for it. Here's a chart. This is the easiest way to engineer, okay? You find out what if you look at the top of the tables, and there's two here, there's an FC number that says 4,000 PSI or 3,000 PSI. That's the strength of the concrete you're going to use. So that matters as far as what strength you're going to get out of the foundation. Then if you look a little further down, you'll see an FY number, 60,000 PSI. That's the steel reinforcement. So you'll find grade 60, grade 40. We'll go through that a little later. But that's the strength of the steel. So if you use grade 60 steel, 4,000 PSI concrete, then you go over across the top, and those are those PCF numbers that we talked about, 30, 45, 60, 100. Then they go down below that, and they'll have the different thicknesses. So these are all nominal. So if it's an 8-inch wall, it's going to be 7.5 inches thick is the wall, or 9.5 or 11.5. So 8, 10, and 12-inch thick. If you go to the left side of the chart, you'll see unbalanced fill height. Unbalanced fill height means this side of the inside of the foundation doesn't have any fill, right? That's the open space. Outside of the foundation, you've got backfill material. So you subtract out the floor, subtract out the distance that the backfill height is going to be. What's left is your unbalanced fill height. Okay, so you're going to take that number. So if it's an 8-foot wall, you basically are going to figure just over 7 feet will be unbalanced fill. Because you're going to have 8 inches of, normally, you'll be down on backfill on a 3-inch floor. So 7-1. Go on that side, look at what your unbalanced fill height is going to be, and then you just go over in the chart, and you can figure out if it needs to be reinforced vertically or not, and then you can design accordingly. So this is an easy way without running calculations. The hard way is actually running computations, and that's ACI 318 has the actual formulas and models that you're supposed to use when figuring that, and you punch in a lot of those numbers, and you can get an individualized plan. The other way is all the structural engineers are using different computer models. It's similar to what the truss manufacturers are using. Punch in the numbers. It's going to give you a base similar to this. Isn't any more special than a table like this. What we're finding is that a good structural engineer that does it by hand, runs the numbers, is going to have a closer approximation of what should happen, and you won't overpay. So you're going to get more value out of those numbers than you will a table or if they're doing it off of a computer model. Computer models end up putting in a safety factor of close to 2 or above, meaning they may double up the amount of steel you may need in the foundation when you're doing this, whether it's block or poured. So keep that in mind when you're dealing with a structural engineer.
The unbalanced fill height, say if you had an 8'11" wall, you'd still be in the 8-foot bracket, not having to go to the 9-foot bracket.
Correct. And that's exactly, and so, you'll see some foundations at an 8-inch by 9-foot, but then you got to make sure that your unbalanced fill height is at that 8-foot height.
Say if you had an 11-foot tall wall and still had an unbalanced height at 8'11", you'd still be in that bracket.
Absolutely. But it goes the opposite way. If the unbalanced fill height, and I've seen this a lot lately, goes above the foundation wall, then you have to factor that in. So you're going to have to make accommodations accordingly. We've seen where, because they may run brick up, they'll run regular cement brick to start with, and then run the grade higher than the foundation wall. You need to factor that into the tables. So it goes both directions. So keeping it dry, this is probably the number one thing that we see that fails is landscapers just don't seem to understand this. You need 8 inches down from the top of the foundation. So we did all this engineering on what height the unbalanced fill is, and then the landscaper comes in and because he didn't want to cut more out of the grade that was there, he backfills it up within 4 inches of the top and then puts bark chips and everything else higher than that, and then we've increased the slope, gotten the water away, except that we may have surpassed what the design criteria is for the wall. On the other hand, we also see where the landscapers won't get enough pitch, so they'll leave it basically flat within that first 10 feet. And then you have a problem where the water's running back towards the house. So that's probably the biggest no-no that we see and that contributes to water problems, which then increases more problems. Talking about if it's a clay soil, keeping it not saturated. If you're keeping the water, surface water away, it's not going to be as saturated, it's not going to be as heavy. Okay? So it's an easy way to deal with it. Quarter inch per foot for 10 feet. The other one is some some planners have forgotten that water retention ponds fill up during heavy wet periods, and there's a set height. So if the foundation or the footings are not above that height, they will flood. And we've seen that happen. And then the engineers come in and we have to add a couple feet of stone in the basement, and their nice 8 or 9 foot basement becomes a 6 foot basement. So it helps on the front end to make sure that you're above the retention pond or above the creek in the back or whatever, and you need to plan for those 100-year rainfalls. You know, that's another thing. About 5 years ago, we had, and I don't know how they calculate this, a 400-year rainfall. One thing that we've seen a lot lately is sport courts. Okay? Well, sport court, for the way a lot of them have been constructed, goes another 8 or 10 feet below what the foundation would be. We have one that was built out in Heartland. It's probably 20 feet below ground, but has a retention pond right behind it. Now, Heartland is sand and gravel. Doesn't take much for when that retention pond fills up to find a vein and overwhelm the drainage system in the sport court. And the owner was beside himself. He couldn't believe nobody thought of this, whatever. The problem was is that the owner demanded that it be set at that height. So, you know, kind of got to be the expert in those cases, but that's what you got to keep that in mind. The only way that was fixed was larger crock, more pumps, pumping the water out. Topographical features. If you're at the base of a hill, you need to keep that in mind. That wall that's on the backside of that hill has a thing that you have to design for, which is called surcharge. Okay? That's additional weight putting pressure on that foundation. And so depending on what your topographical features may be, you got to kind of plan for that. We see a lot of, you know, the houses are designed a certain way. There are some architects, especially if it's a production builder, may not have incorporated the topography of the lot. What they're doing is they have a model. Here's what the model is. They take it out there. It doesn't fit for the lot. They have issues. So it's another issue that we see quite a bit. And then the drainage system, older foundations. Milwaukee has probably when they switched from backfilling 4 feet to within 4 feet of the top, and they backfill higher. Now they have drainage problems. And so that's another issue that seems to run into trouble. Poured concrete wall leaks. It's only going to leak through a couple spots. Improper consolidation created honeycomb. There's a crack outside of a control joint, or it has a leaky tie. A block wall is going to leak if on the outside of the most block walls is a damp proofing. If that damp proofing has cracked or the drain tile has plugged. So those are two. If you're dealing with a block wall, you're looking at the drain tile is probably an issue, or on the exterior, more waterproofing needs to be added. On a poured wall, you're looking at either honeycombs or ties are probably the biggest offenders, and cracks that happen haphazardly. And we'll get into some strategies to affect that. Ties. On the left, what you see are kind of square round ties. Wood forming systems use those types of ties. So if you go out towards Madison, you're going to see more of the wood forming systems. Simon's Forms, which is in Waukesha, you're going to see the square round tie. That's going to leave a bigger hole for water infiltration. It's also harder to break the ties on the interior without loosening it and creating a water leak. So keep that in mind depending on what type of foundation system you're using. Those types of ties, you're probably going to want to use some type of waterproofing or mastic material over those tie systems. The aluminum form or steel form systems are going to have a flat tie. Those are made where you kind of see the little indentations in the tie. those can easily break. It's a flatter system. They still will leak, but usually they leak because they tried breaking the ties too early. They loosen it up inside the wall, and then the water gets through. Okay, the other way it happens is, keep in mind that these are both steel or aluminum. They're also going to transfer heat, okay, which will create condensation on the inside if the exterior ties are not broken. So the little tabs that held on the form need to be broken off. So I see a lot of, there are certain contractors will leave the ties on to slap the insulation on. That's a bad practice. Number one, it's going to bring heat, or it's going to transfer heat or cold, and bring in condensation. And number two, you've also penetrated the insulation, which that's what it's for. The whole system to keep it dry, we talked about drainage. So that's the exterior system. You get the grade correct. The ties that are possibilities of leaking was the ties and the cracks. The thing that collects the water when it comes along the house is the drainage system. So on this diagram, I kind of drew in form a drain. Drain tile is what's going to be used, kind of the old method. I think pretty much everybody has switched to form a drain. But what happens is the water, if it does percolate down along the foundation, gets collected in this stone and drain tile. It's going to come to the inside. There's crossovers or bleeders, which we'll have pictures of. That water comes through, gets collected on the interior drain tile, and is going to come around to a sump basket and get pumped out. Okay? Now for block, if the block, for some reason, and the parge coating gets cracked, the water will actually come inside the block and come and still catch that bleeder and get inside. And so that when that bleeder in here gets plugged, that's when the block, you'll see the water kind of come out the surface of the block, or you'll see that efflorescence. So that's what you got to look for there. Then you know that you might have an issue with the block foundation as far as the drain tile not draining correctly. So as far as it pertains to moisture, the temperature steel, so that's the drain tile. The temperature steel is the steel that's going to run horizontally on a poured foundation around. So when it cracks, the cracks don't open up. So that's an important thing. Good consolidation techniques is when they're pouring the concrete, if they're getting all that cement paste compacted tightly around that stone that's part of the concrete, that's good consolidation. When you see on the surface of the wall, after they strip the forms, and you see all these stones, that was bad consolidation. Okay? That means if you took a core sample or you tested that area of the wall, it's not going to be as strong as some of the other areas that were consolidated correctly. ACI 318 spends a lot of time talking about the proper way to consolidate. It had been in the industry for concrete okay to just stick it or puddle it. Okay? ACI 318 does not allow that. You need to use mechanical vibration. So there's a lot of new tools in the market now. Backpack vibrators, vibrators that are run off of your Makita drill. Okay? The mechanical means is what should be happening if you want to reduce your chances of it cracking or issues with honeycombing. If they're not, if your contractor isn't, need to make sure they are, because that is part of the code. The other thing is water and cement. You need just enough water to make a chemical reaction for that cement paste to react. So what happens is with concrete or mortar is cement, when water is added, goes through a chemical process. And what actually happens is on a molecular level, crystals grow and actually will intertwine and connect to the other crystals. And you need just, and they call it a 1-inch slump or a little bit of water for that to happen. Any water over a 1-inch slump is called water of convenience. That means that's water that's added to make it flow, make it easily workable, make it easier for the tradesman to place. Okay? So At a certain point, the more water you add, you're not getting any advantage on strength. You're actually decreasing the strength. Because if you can picture it, if you're mixing yourself some chocolate milk and you put tons of powder in there, at some point in time, it's not going to taste as good. If you put not enough, there isn't any there, you're not going to taste it, right? On the cement, if you add too much water, you actually decrease the strength tremendously. For every 1 gallon per yard that you add, you lose 100 pounds of strength. So we looked at that chart, 4,000 PSI concrete was what we were shooting for. If they put too much water in, you're going to be substantially below that 4,000.
Do you do a slump test at the site when you're
We do intermittent, yes. We'll do a random sampling once a week, slump tests and cylinders. And if you go to a commercial site, that's part of ACI 318, is you actually, for every 50 yards you pour, you're supposed to take 3 test cylinders. And you'd also do slump testing with that. This is kind of what we went over here, so we'll briefly go through that. In this case, it shows a 4-inch drain tile. It's going to be able to move water a little quicker than a 3-inch drain tile. That's the Forma-Drain. It's very important that you make sure that the stone is in place either before you pour the footings or before you leave the site, because if the soils filter in because of a rain or something, it'll corrupt the drain tile. Because it's not, when you put in 3-inch or 4-inch perf, you're putting that in after the fact. It's clean, you know it's not corrupted, you know that it's not full of dirt and silt. However, Forma-Drain, once it's in place, nobody pulls it back apart and checks. So the stone needs to be in place to make sure that something is there to protect it, keep it filtered. The connectors or crossovers which connect, this was the original Forma-Drain when they went for material approval for code. They could get away with 2 4-inch or every 15 feet a 2-inch crossover connecting the outside to the inside. The current code now calls for 15 feet. More is not better for Forma-Drain. CertainTeed did studies, and actually the increased water pressure will actually slow the rate down that the water can move. So if you put more crossovers in than 15 feet apart, what you'll do is slow the system down. So more is not better in this case.
I thought UDC said that those leaders were supposed to go at 8 feet at center.
For a 3-inch drain tile system, it's 8 feet on center.
For Forma-Drain,
Right.
15.
Yep.
They changed it from 15 to basically just 4, isn't it? You don't need 15 on center with Forma-Drain anymore either.
It depends on the size of the house. That's just a different picture. West Bend area, Slinger area, a high silt content. Okay, there's a lot of sand mixed in with the clay in those areas. What'll happen is it'll plug it up. What the picture is on the left, this is of the same house. What ended up happening was they went to go connect the sewer and water at the street. They had to pump out the water because the hole filled up with water. They pumped it to the back of the yard. They then flooded the yard. That water ran back towards the house, came down along the foundation, filled the drainage system with silt. It's completely plugged. So keep that in mind. Most foundations that we do up in that area will look to see how much silt or fines there are in the area. Highly suggest putting filter fabric over the stone. There is Forma-Drain that has filter fabric on the outside of the drain tile. No, it's not a good idea, because what happens is all those fines, you can see how small it is. Once it's diluted with water, will go right through the stone, end up plugging that. So you haven't done yourself any favors. Okay, then it's just created a problem even closer, and then the water won't get there, and it'll start coming through the wall. So this all has to get, that all got tore out, dug out on the outside, filter fabric put in, and that was how that one was fixed. But filter fabric is probably $3 a lineal foot on the outside. Excavator can put it in, or your contractor when they put the drainage stone in. That's another picture of it before it was dug up. We talked about the consolidation. The industry, like most industries, chemicals are changing the industry. You can pour, we talked about the right amount of water. You can get better placement without adding water now with chemical admixtures. There's a lot of admixtures that will, and they call it self-consolidating concrete, where actually you can put the admixture in, and if you had a cone of concrete a foot high, and it was a nice cone shape, you put the admixture in, it'll go flat. It'll just become, it'll look like solid water. It's not, it's a chemical admix that's created that. So placeability can be enhanced with chemical admixtures that will not reduce the strength of the concrete. It'll actually add to the strength. So that's something to keep in mind. We talked, I had mentioned about the sport court. When you're pouring 20 feet of wall to get proper consolidation and placement around the steel 20 feet up in that small cavity, you have to use these admixtures. So you have to get involved in that process with your contractor, find out there's ways to move around that. The other thing we talked about is the vibrators. That, again, is also changing. That has to be part of that pre-planning, pre-construction meeting with your contractors. What are you guys using to consolidate? What's your plan of attack? Are you using an admix to adjust for that? Also, make sure they have enough people on site. I see a lot of crews will go down 3 guys. The reason they could pour with 3 guys, yes, they may be using a conveyor or a pump, but they're also adding a lot of water, which in the end is going to hurt you. More water, besides losing strength, there's also going to be more cracks because it shrinks more.
Can you consolidate too much in one area?
Yes.
Rate that you have to move?
There's a certain rate. There's a certain training. That's a whole nother 4-hour deal. This is probably 10 feet down in a 18-foot wall. And you see we didn't get proper consolidation. So now what you have to do is you got to take that stone out of there, get back to what's strong, and then fill it in with a grout or another type of cement that will actually expand so it doesn't leak. Okay, a hydraulic cement. Control joints. ACI 318 is very particular on this. You see it in your sidewalks. You see it in your floors for your driveways. You need to have control joints in. One thing I can guarantee in life, concrete will crack. Okay? It's going to crack. If it cracks, water's coming through. This is looking down from the top of a foundation wall set up to pour. No concrete yet. There's a V on each side. That's going to form the control joint. That's where we want it to crack. When it cracks, the piece that's in there, and it could be steel, it could be vinyl. There's numerous suppliers for this, is a water stop. Should be every 15 feet on minimum. ACI 318 is very particular on that. On a residential side, very seldom are control joints used. This saves epoxy problems, leakage problems. This is probably the easiest thing to do that anybody can spec out and maintain and make sure is done right, is a control joint and then done properly. The steel is that temperature steel. That's going to keep it tied together so when it cracks, you're not going to get the spread. The concrete's not going to shrink enough to pull apart. It's kind of a placement for wall. Keep in mind that the structural steel is going to be your vertical steel. The horizontal, or the pieces that the dots are your horizontal steel. That's your temperature steel. And it also combines the vertical steel. Keep in mind that your sill plate connection is what retains the top of the basement, because a basement is not a retaining wall. 9-foot walls, you need to use 5/8 anchor bolts. Code only calls for 1/2 inch. If you go to the spec, Simpson spec site, 1/2 inch will not retain the top. The bolts will actually fail if you get a strong enough or heavy enough backfill pressure. So we need that sill plate to restrain the top. If your bolts fail, it's not doing that anymore. Size and spacing of the anchors, if it's a Simpson, make sure you follow their charts. Also keep in mind, if you're using ACQ treated lumber, that you're using double dip galvanized and zinc plated fasteners. I see a lot of foundations with non-galvanized bolts. The treating will eat those alive. Guys that are doing decks probably see it all the time. If you're not using the proper treatment on the anchors, they're going to fail after about 6 months to a year. It's pretty amazing if you've seen it happen. This is just a code layout for where the wall goes, higher or lower. This would be your window steel. Keep in mind, there are markings on the steel. If you go to Menards, they only carry grade 40 steel, okay? That is the low man on the totem pole. It's not going to do much good on a structural application. You need to use grade 60 or above for the steel. This kind of demonstrates, and I'll show you what you're looking for on the steel. Every piece of steel is stamped. Most steel comes from China. Keep that in mind. It's boated in Chicago for this area, and then it's going to get trucked up. If it's not purchased from a Gerdau or a Midwest or a place like that, there's a good chance that the steel is not going to be the high quality that you need to mean anything when you're dealing with structural calculations. One quick thing on slump, and then we'll go. This is kind of what we talked about. The amount of water, when you put water in the concrete, this is how you measure it. That cone at the top left, you fill that up, you flip it over, it's 12 inches tall. When the next picture down, he pulled the cone up, it slumps. He measures, and the distance from the top of the cone to where it's slumped is the slump. Okay? So the less it slumps, the less water it has. So that's the easiest way to measure it. It doesn't take very much to do it. The last picture over here, and then we'll get you guys out of here, is measuring the strength of the concrete. You could take core samples or you could take cylinders. It goes into a press. The press pushes on it, and at whatever poundage it cracks, that's what it measures out to. So that's a cylinder as it's being pressed. So it's outside. What you'll usually have is a plastic container that you take the cylinder, and then it goes in this machine, pushes down, and how it cracks is also measured. And that was the 1 extra gallon. Keep in mind, we are in the most severe climate. So when dealing with exterior concrete also, provisions need to be made. That's the end. Thank you very much. Have a good rest of your day.